we have to figure out the value of sine pi over 12 in this form and in this form. So this form will come from half angle formula and this one will come from the compound angle formula, and I show you how we use those two different forms. We see from the cosine double angle formula I have this. If I add 2 sine square x both sides and subtract cosine 2x both sides, then we get 2 sine squared x equals 1 minus cosine 2x. And then if you divide both sides by 2, you get sine squared x equals 1 minus cosine 2x over 2. And then if you take the square root on both sides, you get sine x equals plus or minus square root of 1 minus cosine 2x over 2. So if you remember this formula here, then you can deal with this problem. So we'll be taking this formula, and you can see pi over 12 is an acute angle. It goes in the first quadrant, so we'll be using only plus sign. So we are using sine x equals square root of 1 minus cosine 2x over 2, where x is pi over 12. So if I multiply both sides by 2, I get 2x equals pi over 6. So then sine pi over 12 is coming out as 1 minus cosine pi over 6 divided by 2. So when you plug radical 3 over 2 for cosine pi over 6, it look like 1 minus radical 3 over 2 divided by 2. Just to avoid this 2 here, in the numerator and denominator we can multiply by 2. So you get 2 minus radical 3 over 4. So you can write 1/2, you can take outside, and then you have 2 minus radical 3. Now if you compare this one with this problem here, you can easily see that you have a equals 2 and b equals 3. So we have got our AB using this formula. Now I'll go in this format with the compound angle formulas. So you can see pi over 12 can be written as pi over 3 minus pi over 4. These both angles here are the reference angles. Just like pi over 6, we had a reference angle. But when you use the double angle formula, we get this format. When you use just this reference angle, x minus y type, sine of x minus y, we know the formula. Then we'll see how we end up with our final result. We are writing sine pi over 12, which is sine pi over 3 minus pi over 4. So apply sine x minus y formula, sine x cosine y minus cosine x sine y. Now plug the values. You have sine pi over 3 is radical 3 over 2, and cosine pi over 4 is radical 2 over 2, minus cosine pi over 3 is 1/2, and then sine pi over 4 is radical 2 over 2. You can see you have a common denominator 4. In the top you have radical 2 times radical 3 minus radical 2. So we can factor out radical 2, then we have radical 3 minus 1 over 4. Now if you compare with these, you can see that your a is 2 and your b is 3, because a is inside the radical sign and b is also inside the radical sign. So we got our a and b. We just want to verify our results from both. So in the calculator, we need to check our mode in radian. So we have in degrees, we choose radian. Now check the value of sine pi over 12. So we have sine, and then I have pi divided by 12. So this is the answer I got for sine pi over 12. Now we'll see what happens to this value and this value, and they must be same. So we type our answer. Sine pi by 12 gives me 0.2588190451. When I type this result here 1/2, and then it's square root goes on all of 2 minus the square root of 3. So that's why it's parenthesis like this. That gives the answer same. You can just compare. Now I'm writing the third answer. I have radical 2 first, and then I have within parenthesis radical 3 minus 1 and divided by 4 and enter. See the answer? Exactly. All three answers are same. So we got our answer. So in this case, your A is 2, B is this 3 here. In this case, your A is 2 again, B is this 3 here. Okay, so we are done.